However, in this video we will solve example 4.6 from the book Applied Thermodynamics, McConkey and TD Eastop. Here is the statement of the example 4.6. Steam at 100 bar 375 centigrade expand isentropically in a cylinder behind a piston to a pressure of 10 bar. Calculate the work done per kilogram of steam. Now the pressure P1 that is given is 100 bar and the temperature T1 that is given 375 centigrade. If you see the state point P1, T1 lies in the superheated region. If you see from the portion of the steam table, that because the 360 at 400 centigrade in between the 375 centigrade will lie, and so it at pressure 100 bar it will lie in the superheated regions. So our state point 1 is in the superheated region, so we can say that it is at the outside of this curve. And the pressure P2 that is given is 10 bar. This is the curve line for the high pressure, that is P1 100 bar, and this is the lower pressure line P2 that is 10 bar. Now from the state point P1 T1 that is at the superheated regions, its corresponding entropy we need to calculate, but remember the 375 centigrade is not available in the superheated regions. So in this steam table we will do interplotting formula to find the entropy and its corresponding. So the internal energy U1 in first state point, that is we calculate that from the steam table by using the interplotting formula. You know how to use the interplotting formula. I will summarize here how to use. That is equal to UA plus UB minus UA divided by TB minus TA multiply by T1, the temperature at which you need to find the U1 value, then TB. So from where you will find the substrate value, it's very simple. It's from the steam table, you can easily judge. This is TA value, this is TB value, and similarly this is UA and this is UB, and similarly this is SA and this is SB. So in between, when you are finding the value for the corresponding properties, the upper and lower limits, you can say the upper limit is for subject A and the lower is for subject B, at which you are finding the interplotting formula. That is 2729 plus UB, that is 2832 minus UA, that is 2729 divided by TB minus TA. If you subtract TB minus TA, that will be 40 centigrade multiplied by T1. Then what is T1? That is 375 centigrade minus 360. So when you subtract it, it will be equal to 15. So after simplifications you will get the value U1 that is equal to, remember the interplotting formula will give you the approximate value, not the exact value. So the U1 value will be equal to kilojoule per kg. Okay, next we need to find the entropy. Similarly, we use the same interplotting formula SA. For this time we use entropy in terms of internal energy, SB minus SA divided by TB minus TA multiply with T1 minus TB. So just put the values from the steam table and you will find the entropy at state point 1, that will be equal to, I hope you know that what is SA and SB. These are SA and SB value, these are TA and TB value just by putting in this formula. Now come to the state point 2. We have given the pressure P2, that is 100 bar, 10 bar. After expansions, isentropic expansions, when you did the isentropic expansion, the pressure from P1 dropped to P2. So where our state point lies, for this we need some at the 10 bar, the entropy at the saturated line, that is 6.586. It means the entropy, that is, this is Sg2, let's say the entropy Sg2, that is equal to 6.586, and the entropy, remember, it is isentropic process, isentropic expansion taken place from the pressure P1 to pressure P2. So it means that the S1 entropy must be equal to S2, and that is equal to 6.084 kilojoule per kg. This is also kilojoule per kg. If you see that this entropy, S2 entropy, is less than Sg2, so it means that it will lie at the left side. So this point 2 lies within the wet regions. So we can say that the entropy 1 and 2 is equal, and that is inside this wet region. So for that we need the dryness fractions also. Now from this saturated steam table portions, the SF2 value is SF2 value, that is equal to 2.139 kilojoule per kg. Now simply subtract these two values, this SF2 from Sg2 value, you will get SFG2, and that is equal to 4.47 kilojoule per kg. When you subtract this SF2 from Sg2, you will get this value. Now we know that S2 is equal to SF2 plus X SFG2. To find the dryness fractions, just write the expressions X, that is equal to S2 minus SF2 divided by SFG2. Now simply put the values and you will get the dryness fractions. What is the S2? That is 6.084 minus what is SF2? That is 2.139 divided by SFG2, that is 4.447. So after simplifications you will get the dryness fraction, that is 0.889. Next thing we need to find is U2 at the state point. At this point you will need to find the internal energy at state point 2, because without knowing the internal energy with these two state points, you cannot determine how much work is done by this team. The internal energy U2, that is equal to UF2 plus X UFG2. So from the saturated steam table at 10 bar, the UF is UF2. Here I am writing the value, that is 761.7 plus dryness fraction 0.889. UFG2 value, the UFG2 value means the difference of this UG minus UF value. So what is UG value? That is 2584 minus UF2, that is 761.7. So after this simplifications, you will get the internal energy at state point U2, that is 2381.5 kilojoule per kg. So these entropy at state point 2 and at state point 1 has been determined. Next we need to find the work done that is performed by the steam after expansion, that is equal to change in internal energy, because in isentropic process the heat additions neither heat taken places occur, so the heat additions and heat rejections is 0. So the total work will be equal to change in internal energy. So that change in internal energy is equal to U2 minus U1. So what is U2? That is 2381.5 minus 2770. After subtractions, you will find the work done by the steam, that is minus 390 kilojoule per kg almost. This minus sign say that work is done by the steam. Thank you so much.